We had pockets of excellence in several different business units. And if you don't know about DPR, we're a pretty large company. We're approaching about $8 billion worth of work this year, and the pandemic hasn't really slowed us down. We realized that we needed to start getting serious about a strategy around reality capture. If you want to know how deep the rabbit hole goes, this is where we're headed.
From a GC side, we deal with all the players from start to finish. And there are a lot. There are a lot of design teams, there are a lot of subcontractors and trade partners, a lot of facility management, maintenance, and where we come in as Field Technology Group is bridging the gap between our virtual or VDC teams and getting that information out to the actual installers.
So you guys met me earlier. My name's Josh DeStefano, and we're from DPR Construction. I actually want to let these guys introduce themselves and then get into some content here. But what we're going to talk about is what we call field technology at DPR Construction. We'll probably refer to Field Technology Group, or FTG, here and there. And that's sort of around the initiative that we've had around reality capture. So before we kick all that off, I'll let Ivy and Josh introduce themselves.
Well, hello again. I'm Ivy Frank. Again, I work at DPR. I've been here for about a year, and I do reality capture for the Northeast.
Josh Engelbrecht. I am with our Southwest region, currently working out of Phoenix. I've been with DPR for about 5 years as of last week. Josh kind of took me under his wing and brought me up, knowing all things VDC and field technology. So I think together we help form somewhat of a national and company-wide field technology group with passionate folks ranging anything that we'll get deeper into, but surveying, scanning drones, pretty much everything at this conference and how we utilize it. So, yep.
Good stuff. So I'm Josh DeStefano. My previous role was a Southwest Virtual Design and Construction leader in DPR. I'm currently transitioning to be the West Coast Innovation leader, which basically just means I'm working with more the forward-facing stuff, testing out different things and getting into new technologies and working with our strategic partners like Faro and Leica and all these guys to figure out how to best implement these technologies. So if you're a contractor, and especially the contractors in the room, so we're a general contractor. If you want to know how deep the rabbit hole goes, this is kind of where we're headed. We use this technology for a lot of different stuff, and I want to kind of introduce you guys to the history of it. A lot of you guys have talked about the development of using this technology at your firms, and kind of wanted to give you guys a little bit of our background. So I talked about this Field Technology Group, and I would say it pretty much started back in like 2016. We had this summit where we decided that we had pockets of excellence in several different business units. And if you don't know about DPR, we're a pretty large company. We're approaching about $8 billion worth of work this year. And the pandemic hasn't really slowed us down just because of the types of core markets that we get into, which is actually a little bit of a caveat that we work in the right projects and the right environments for this type of stuff, much like the manufacturing and the energy that we saw earlier. And so the projects that we do are life science, healthcare, advanced technology, the data centers. We're doing higher education and a lot of commercial stuff. And like I said earlier, we do projects of different sizes, and some of these projects allow us the ability to test this technology. So anyway, they're great projects, but we reached a point in 2016 where we realized a lot of different people in our company were starting to use the hardware and software. We had a couple scanners in our possession already. We had a group in the Bay Area that was doing a lot of scanning and essentially offering it as a service to outside companies and DPR internally. And we realized that we needed to start getting serious about a strategy around reality capture. And we had a summit and we sort of started getting serious about it. So since then, we've had some growth. It went from being just reality capture and just focusing on what we were doing with laser scanning to include field engineering, building control, survey and building control, just like the guys were talking about. And I would say that's probably still, it's still up and coming for us. We're still, like I said, we're a general contractor. We're not a surveying firm, but we do our own layout. We use robotic total stations and things like that. So building control is really important to us, and Josh is going to talk a little bit more about that later. Like I said, it started with laser scanning. We were really early in the aerial mapping game. We were using some of the open source drones that 3DR had in the Iris 1 and the Iris 2 with GoPros on them and catching them because they would run out of battery. And yeah, that really happened. Anyway, so now we have a fleet of drones. Josh just got a Matrice 300 for his project with like a thermal camera and all this crazy stuff on it. So we've seen it come a long way. And then this idea of data integration or data mobility, this is sort of like our catch-all. This is more of a miscellaneous, like BIM to field is not what we wanted to call it anymore. It's more than that. It's about augmented reality and VR and sort of, just sort of trying to fill that gap of integrating some of this other information into other processes and sort of workflows and different, get it out there to the team. So, folks talked about this idea of the cyclical nature of reality capture and construction, and this isn't a representation of that cyclical nature, but it begins to lay the framework for it, right? So this is sort of like how we look at it. We're a builder, and we do a lot of virtual design and construction, and that's a big thing for us. And so we wanted to look at, how can we use reality capture and laser scanning to have more predictable results. And so we looked at these steps of validating the existing conditions. A lot of folks have talked about that over the last couple days. The VDC components get into modeling what we plan on building. And then we sort of start merging the field technology and the VDC and build what you model, where we want to actually do model-based layout, and now we're using a model to create layout points in order to put footings or framing or whatever out in the field. And then we can use reality capture to start having data-driven quality control, where we can eliminate errors, do quality control very frequently if we want to, and essentially manage the risk there. So this is sort of putting that into that cyclical context of saying, well, if we have data from the previous project, and we're talking to some of our bigger clients about this that have a portfolio of buildings that they're managing, or they're constantly trying to templatize things or do these different things, that it's like we need to capture these jobs, just like somebody mentioned and asked earlier at the panel. We need to be capturing as we're building, so that the next time you want to do something, we have really great information to go by. Somebody that was up a little while ago talked about data from 2016 that they're still using today, 5 years later. So everybody's interested in protecting that interoperability, and so it's going to start to look like, well, these are some examples. It's going to start to look like this, right, where the previous project's data starts to get into the next project's data, and especially if you're an owner managing a lot of facilities, or facilities that get renovated a lot, you're going to want to do reality capture. So one of the things that we started to realize is that we needed a framework around this. So I'm giving you guys a little bit of peek into kind of behind the scenes, where we started taking a look at how we procure reality capture services in-house. We sort of look at it as a service business within our company, and so we wanted to figure out a way to plan out the work. And although this chart on the right looks very simple, folks that have tried to do this and tried to figure out, like, how do I categorize use cases and objectives and like really make this understandable to any degree, know how difficult it is to sort of take reality capture and try to put it into one chart. But we did halfway decent job of saying, all right, let's start with our general use case. Are you looking at existing conditions on your job? Are you going to do building control, progress documentation, quality control? What are you doing? And that's your sort of use case, and then we dive into the objectives within that use case. And then we start to dive into what technology are we using in order to capture that information to meet that requirement. So a good example, we've seen different examples of folks using drones, laser scanners, photogrammetry, 360 photos, and video to validate existing conditions. So there's a lot of different options. So when we look at a project, we want to figure out what are we going to do, and how are we going to capture this information, and that's going to be based on a lot of other things that we might want to do, because if you get a scan, you might be able to do more with it than you planned, kind of thing. So we've created, a framework for this to try and plan it out. On some projects, we go to the nth degree to really understand the process, and so this is a quality control process that we're using several different tools. If this looks like BIM execution planning, it's not an accident. Like, that's kind of where these ideas came from, is how do we plan this out? How do we work this workflow out? And this particular workflow looks really, really complicated, but some of it's automated. There's several teams involved, and really the point is that this might be a 4-hour process. It looks like a week, but it's not. So now I'm going to hand it off, and we're going to talk a little bit about some examples. We've got some examples of building control and why it's important to the things that we do in VDC and reality capture, and all that. And then we've got several project examples to give you guys an idea of, now that we've taken the first step to figure out a framework and start planning this out at our company and using it in our different areas, what have we seen? What have been the use cases? And we've got some great examples that'll give you some visuals for some of those deliverables as well.
So I'll take survey and building control. So this pretty much is at the very beginning of your project. I know we're all, from looking at this as from different perspectives. From a GC side, we deal with pretty much all the players from start to finish. And there are a lot. There are a lot of design teams. There are a lot of subcontractors and trade partners. A lot of facility management, maintenance, and everything that goes into it. We see all of those different parts of the job. So where we come in as Field Technology Group is pretty much bridging the gap between our virtual or VDC teams and getting that information out to the actual installers, the guys out, the teams out there with hammers and actually building it. And so survey and building control is, where are you placing that building, or where are you placing that site? So every job site has it. Walking around downtown here, I notice about a dozen. I am very nerdy when it comes to that, and we'll stop and take a picture. If you've ever been hiking and reached a peak, there's most likely a monument that was part of the 1927, and they did it in 67, to map out pretty much the entire country. So this is probably the biggest problem that is always at the root cause, is survey control and being able to tie it back to some sort of reference point, okay? Anybody can take a measurement, but where you're measuring from and what you're comparing to is the key to our entire success. So taking that information from the VDC at the start can be a number of things. So next slide can show basically our control map. So we start with our Alta survey. We start with that, the third-party survey teams that will establish control based on known coordinates around each city. And then what we do is we have that control be established on site. So now we have a site network of control points that we can perform a traverse, and then we can share those coordinates so our trade partners and even our internal SPW can do their correct layout. So everybody's matching, right? And through the different phases of the job, we rely on different types of control. networks. So we have our primary, which is mainly the boundary of the site, so long distances, hard angles, all the upfront work. And then we have our, secondary and supplemental that are still on site but outside of the building. And then once we get interior, that's when we really start getting that super tight accuracy that's needed. So we'll establish what's called then building control. So we're seeing every part of that throughout the job. And the importance of this is that what everybody was saying yesterday, today, we can capture all the data in the world, but if we don't know geographically where it's at and it's not placed right, it's literally just floating, in space. So in order for us to do these different checks with all the different software platforms and everything, we need to have a model that is aligned to our real world or, real life capture. Okay, so all of that ties back into it. Even making sure that our model is on our correct state plane coordinates in the beginning. That sets us up on the right foot. And as DPR, we're slowly starting to see, hey, if we start these jobs off right, then that's going to be a huge, huge success and knock down all of our roadblocks.
Yeah, one of the reasons I was glad that we included this slide is because we had the survey and building control guys up earlier, and they were talking about compounding error. Was that it? And this sort of visualizes it, because if you have error in that outer traverse, and then you introduce more error into the primary control, then introduce more error into the secondary control, you're adding up all of that error into something that's way off.
And we'll see it. We'll
that
see our
happens all the
plumbing
time.
guys say,
Yeah.
hey, electrical is off 2 inches, or this point is off, an inch, and you guys, and then we have people literally fighting in the field saying, my control is, I'm good. I know I'm in the right spot. So we need to have this control network, and maybe it's because those two guys were setting up off of different points and carrying or compounding error from those different setups. Okay.
Yeah,
So
and so-
it's all the time.
Right, and so where we're headed is we're now recognizing the importance of having people who understand this stuff on staff and that have the background in surveying that can help us maintain control points instead of crawling out our third-party surveyor like every week to maintain stuff, so we can go through and check. All right, so now we're going to jump into some of our laser scanning success stories. And what I like to do is we probably could dive into some case studies, but I feel like we get a lot of those. We get a lot of, here was the entire project and everything that we did for it. And what I think in some ways sets us apart is that our adoption is pretty widespread. So there's projects on this list that are literally from all over the place, but sorry, go ahead.
So, like I said earlier, we're seeing every perspective of that job. The different trades and different design teams have different, things that they focus on and hone in on. And one guy's one team is concerned about the steel placement. Another team is worried about the floor flatness, right? So we're looking at what reality capture allows us to do is capture everything. It takes the horse blinders off. We're now not only just going after that one scope, but we're trying to get everything. So then we can overlay it, compare, and provide feedback to all parties. So when this is a good example of something that we've been doing a lot of, more so in our central region, is I think we're building a 67-story in, I believe it's Austin, and we have very tight tolerances for those elevator shafts. So we cannot get outside of those, and if we do, we need to come up with a game plan of how we can fix it or where those issues need to be addressed. So we're leveraging probably a handful of the different platforms that you guys see upstairs. And so we're trying to leverage all of those to get to a final end deliverable that is very easily digested, right? We can't just spit out a point cloud, or we can't, a lot of these tools and a lot of these software platforms, we have limited access to, and we have limited people that have the knowledge and experience to leverage those. So a lot of our end deliverables end up as pieces of paper or PDF. That is we're taking it and we're making it very, very simple to use, and then to give to the folks out in the field to then either make the corrections or high five and say, hey, this is awesome. That is really, those are the times where I love my job, is when we get called out to verify something or scan something. I think like the next slide is a really good one, because we're showing floor flatness, and we're out there with the teams that are pouring the concrete. As the mud's coming out of the truck, we're setting our scanner up, and as soon as they're screeding and floating, we're scanning, and we're telling them, hey, you guys are good, or oh, hey, you guys there's a 5A slow spot right there, and then we can go out and verify it, right? And there is nothing, that's why I'm in this team, is because we're builders to our core. This technology allows us to give analysis and feedback way quicker than we could have in the past, but the reason why we work at DPR is to build great things, and this aspect of it is one of our core values of Ever Forward. So it's really cool to get that and still be out there with the teams in the field, still having your tool belt on, and getting to do those. And then, so one other aspect or one other use case and I know a couple of the...
Sorry, I didn't know this had animations. That was fun.
Oh, did it? So one of the other things too, that's the last slide was pretty much regarding our self-perform concrete. So that's what we've adapted our tools to do, is provide, because that benefits DPR, that benefits our quality and our actual company, right? Puts money back in our pockets. Well, what we're doing and what we've been challenged to do is how are we putting money back in everybody's pockets, right? So quality across the board is the key. Pre-pour scans is one that is pretty much the same thing as just quality. Everybody's calling it quality, but we're finding different aspects of the job and different scopes to then provide feedback on. So using different platforms, different workflows that we're again trying to standardize as being a national company and working with hundreds of teams, is kind of standardizing those workflows and making those optimized, least amount of steps possible and as easy as can be, pretty much. So what we're doing is we're taking the data, if it's from a drone or if it's from a laser scan, depending on what the tolerance is that we're looking for, and we can then overlay that into our model, whether it's Revit, CAD, Centu, Verity, and get that feedback and that analysis quick, and send that out to our team for a somewhat pass, fail, or make corrections phase on that. So, cool.
Yeah, floor flatness was a big deal for me in my journey in reality capture. We were looking at buying a scanner in 2015, and I ran across Philip Lorenzo, who's at Struction Site, and he introduced me to Josh, and Philip was working on the Rhythm software, and told me that the standards had changed and that we could use laser scanners to measure floor flatness, and that I dug into it more and realized that you didn't need a third party unless the owner requires it. But then on top of that, there was a whole lot of information that we could get out of just doing that floor flatness, not only to understand what we had put in place, but to understand any challenges that we might have down the road. So for us, it was getting into, and there's also different levels or sort of different areas of floor flatness. Like we focused on the ASTM 1155E or whatever it's called, standard ACI spec of the floor flatness, but then added the contours, added the heat maps to try and give our teams a better idea of where the issues were, That was a big thing because the floor flatness numbers don't really give you that. So
Here we go next, please.
oh, we talked about this one. Okay, so
Yeah. So part of this whole initiative, and what Josh is saying, we're really honing in on the quality, but also how do we get that information out to everybody in a simple manner. So this really kind of kicked off a couple years ago when we had a job that had very, very tight tolerances, and we really needed to impress this client, and we wanted to show them, why did you pick DPR? Right? So we're throwing everything that we can at this job to make sure that we're building it, we're placing it right the first time. We're not doing any rework. We're making that goal of no rework and zero defects that's our goal. So we don't want to have to install something, then take it out or change that in any way, because overall efficiency and quality. So a couple years we had a job for ASU. And we said, hey, we're gonna really, it doesn't matter of cost, right? We're going to scan as much as we can, and we're gonna look at everything. We're gonna compare everything. We're gonna look at this analysis. So what you can see up on here is all these different locations. Like, great if we have a BIM model and we save viewpoints or we put it to Cintu and that. But how do we give that then to somebody in the field that then can go out and actually make those corrections and knows where those corrections need to be made? And so what we do is we try to take that information, like I said earlier, make it very simple, show them the direction where that conduit or where that element needs to be actually moved, or that we're signed off and we're good. So if we have a concrete pour that we're not pouring and things are locked in the wrong place, now we have a pipe that's outside of our drywall, right? So we're trying to make sure to minimize any of the rework, and that looks good to the clients. And then they not only see these deliverables, but then we're able then to do the wow factor, some of the videos that, they have up on the TVs and that you guys were showing. That's all great, that's awesome, and it really is a wow factor. But how are we actually, as a GC, how are we giving that benefiting from that information on a quality side? So this particular building, it's going to be on the next slide as well. So we scanned every floor, every pre-pour, and every post-pour, compared it to the model, found all these issues. The slide previous showed like 40 issues on one pre-pour. Why? Why there's so many issues? So we started pointing out what the holes were in our boat. If our BIM and VDC side is just now finalizing coordination, how is somebody installing that with confidence that it actually matches that model, right? Our guys are doing our entire teams are doing a great job at coordinating and designing everything up front, but it's all for nothing if that updated information doesn't make its way out to the field, okay? Or if we're then, so there were 2 or 3 factors that we realized is, hey, the teams that are out in the field, they don't have updated drawings. If they're walking out there with paper, that's just like a red flag. And so we need to know that they have that right and updated information. So anyways, when it came down to it, it was outdated information. It was kind of miscommunication, pretty much, again, bridging the gap from VDC to the real world or the job site itself. So finding all these issues on each floor, 40 to start, and we started noticing those issues going down. By the end, we had almost 0 issues. We had maybe 1 or 2 things I was pointing out.
we were not self-performing this work, by the way, so just so you know.
Yeah. So, yeah, we installed everything wrong. No, that's not what I'm saying. So we did an analysis on, we kind of had a team huddle and started going out. We started correcting the problems, not just the install issues, but the overall communication. Well, we started seeing that as we got to the top floor, there weren't any issues. And then we went back and we looked at, hey, how much would this have cost us in rework or a design change or an RFI or something like that. So we put a cost per scope item. In this job, our budget up front was $57,000 for scanning, pre-pour, post-pour, everything really. We ended up saving the job over $270,000 by finding all those issues, correcting them before they happened, and the team, I believe this job actually ended up with 0 defects and 0 rework specifically for our self-perform groups. So that was an amazing goal to hit and just awesome opportunity to be a part of. So.
You next.
Drones. So, no worries. So like I said, that's laser scanning, right? So how many different pieces of equipment can we use to do a specific job? Which one is the right one? So sometimes we're not trying to meet that 1/16th tolerance that we fight over every day. Sometimes we need, an inch, or we just need to verify that it's installed. We need to do it quick. So we have to evaluate what the situation is, what the scope, what the tolerance is. We have to take that from all of, even in the specs, but also our own quality program. And we need to leverage those. So in what we just discussed, we did the same thing with site aware and with and UAV data for those pre-pours, just to do a comparison. And it's the folks in the background that are comparing those data sets and saying, and providing those tolerances of what we can hit. And those tolerances getting tighter and tighter because we're comparing those data sets and figuring out how we can then start to get aerial mapping and drone data to look as clean and crisp and accurate as static point clouds. And I think we're heading in the right direction. And it's amazing to see everything that's here. So using the same, pre-pour analysis with, with drones, we're also, pushing the boundaries on using 360 photos and video walk and production tracking with all of these different tools that we're provided with. So UAVs has made it very easy to capture large amounts of data, as everybody kind of hit on earlier, and it's getting, again, closer to what we need it to be to meet those tolerances and to be able to give that analysis that we're being held to. So I think at DPR, I think we have nationally, I think each business unit has 2 or 3 drones each, and we're using them quite heavily, and I think that's going to end up going up, especially after this conference and hearing all the cool things that we can do.
Nobody knows how many business units we have, so
yeah,
it's probably like
so we probably have
40 or 50 drones.
Yeah, and
I don't think it's 100.
They're all different too. They all range in size and quality and what the use case is. So we really, as a company, and Josh leading initiatives, we've tried to leverage our collective strengths and figure out, okay, who's got what and what are you using it for, and coming up with a standard at DPR, similar to that table that you was showing earlier, is which one do we use? That's the hardest decision. We can master the technology, we can master the workflow, but it's finding which one is right to do it and most efficient.
Yeah, and I talked earlier about knowing the life cycle of the equipment and sort of planning for that. Another side of that is, how are you going to manage your equipment? It's sort of a slippery slope to start buying your own stuff, and then what do you do with it? Where is it? Who has it?
Yeah.
When was the last time it was calibrated? Like all this kind of stuff. So part of what I do is I help manage our fleet, and I should know how many drones we have, but unfortunately we didn't do it. We didn't think through it ahead of time, and so we've started managing our fleet a lot more closely than we have in the past. But there's also a mix of us buying drones and our clients buying drones, and then people just buying them and not telling anybody about it, and different stuff like that. So another like word of advice is manage your hardware. But anyway, we can move on.
Yeah. So, and then documenting that job throughout the entire life cycle, right? We're going to switch tools. We're going to switch methods. You going from GPS to using total station, then interiors, theodolite, etc., laybot. And so using UAVs is we're trying to track the progress, and then also the data that we're capturing has so much more metadata that's not assigned to it, that we could utilize that. We're only scratching the surface, somewhat right now, of fully utilizing this data and milking it for all it's worth. So progress tracking with drone deploy, that's a big one right now, especially that I'm starting to get involved with. So comparing the data, I think like data back in 2016, so we can compare all of these different data sets and see. We're doing it on a daily basis to help, the progress tracking right now, the job that I'm on. We're tracking the dirt. Where's the dirt being moved from day to day? Where's it being moved from? What's our excavation rates? And then we can start to cross-reference that with our tickets for our trade partners and say, I don't think you moved that much dirt yet. So we can actually kind of quantify this on a more accurate base in a quicker manner to do those things, and it just drives overall camaraderie and everybody working together to get that in just one team mentality. So
I thought you had a spot, Ivy.
I don't have anything fancy.
Okay, you're here for Q&A. Ivy's here for Q&A.
Sure. Yeah.
Okay, so that was basically it. That's a taste of it. We're using 360 photos, all kinds of different stuff. Just wanted to give you guys, some examples of things that that we do a lot, and show you some of the deliverables and all that good stuff. So a lot of times we get the question of what hardware we're using, what software we're using. We've talked a lot about that. We're kind of in the same boat as the ladies that were up here. Ivy talked about it too, that we pretty much have everything, almost. Sorry, Rip It Stowe. But we have a fleet of, I think we have 32 laser scanners, and it's a mix between like a Faro, we have a Regal, we've got a couple Trimbles, and then we have like 55 robotic total stations ranging from mostly Trimbles, a few Topcons, a couple Hiltis, stuff like that. So again, manage your equipment. Software side, we're using a whole lot of different stuff. Ivy's a expert in Cyclone and is a real badass in that software. But we have other folks. Josh uses Scene a lot, and we use that when we do rhythm and some of the quality control stuff that we do. And then obviously we have other scanners, so we have other software, and so we're I would say the one area that we haven't got into when it comes to laser scanning and reality capture has been the mobile game, the mobile side of the platforms. We're starting to get into that now, and we have a team working on a hospital project that's just about to embark on leveraging the NavVis for interior scanning, and I'm really anxious to see how that goes. But with that, I'll close it up and open it up for Q&A.